Okay, so we're looking at solving inequalities, one-steppers still, with multiplication and division. So we have here the multiplication division property of inequality. Slight difference than the multiplication division property of equality, and we're going to discover that here in just a minute. So this first problem here, we see x over 3 is greater than or equal to 2. We can multiply each side by 3 here, and we end up with x is greater than or equal to 6. Works just like inequality. Now come over here and look at this division one. If we divide each side by -5 here and here, we get the following inequality: x is greater than or equal to -4. I should go back over here and check on this first one over here. X greater than or equal to 6. One value that I could plug in here might be a 9. 9 is divisible by 3. So if I had 9 over 3, is that truly greater than or equal to 2? Yes, it is. 3 is greater than or equal to 2. 9 divided by 3 is 3. So that one is true. What happens here if I try a value bigger than or equal to -4? I'm going to try one bigger than -4. Say I try -3 in the original. We'll discover something very interesting here. -5 times -3 is 15, which is not greater than or equal to 20. So this is not true in this case. So that leads us to believe there is something to be said in terms of multiplying, or in this case dividing, by a negative when you're using the multiplication division property of inequality. And one of the rules is that when or if you multiply or divide by a negative number, keyword is by here, it's not when there's a negative number in the problem, but when you multiply or divide by a negative number to get the variable by itself, you must flip or reverse the direction of the inequality. So that's the rule for multiplying and dividing inequalities. Other than that, it works the same as an equation. Let's look at problem 1. What are the solutions of the inequality? It says graph the solution. So we're going to multiply each side here by 3. Notice there's a negative on the right hand side, but we're multiplying by a positive right here. So we do not change the direction of the inequality. The 3's cancel out to equal 1. X is less than -6. Place an open circle here at -6, and we're going to go in the direction that the inequality is pointing there. Values less than -6 would be such as -7, -8, -10. If you have the variable on the left, you can treat this almost like an arrow here, pointing in the direction of the solution set. So anything below -6 will work in that inequality. Let's try this one right here. We're going to take this one, and you can try it maybe on your own, pause the video, and then check with my solution. So we have c is greater than 2. That's an open circle at c, and we're going to shade to the right of that one. Alright, this next one here, we have -3/4 w is greater than or equal to 3. If we want to take care of this in one step, we want to multiply each side by the reciprocal of -3/4. I'm going to wait to put my inequality symbol in there. We're going to multiply by -4/3 on this side and -4/3 on this side. And since we are multiplying by a negative value, we're going to change the direction of the inequality. So here, the negative and negative make that a positive. The 3's canceled equal 1. The 4's canceled equal 1, leaving me with w is less than or equal to. Here, think of this as 3 over 1. You can multiply straight across if you'd like, or cancel first, and then multiply straight across. I'm going to cancel first here. That's a 1. That's a 1. 1 times -4 is -4 all over 1. So I place a closed circle at -4 and shade to the left. To go ahead and try the second one on there. You should have gotten n is greater than 3 for the second one. Graph looks like this. Open circle at 3. Solution set is to the right of that value. All right, dividing by a positive number. Here we go. It says you walk dogs in your neighborhood after school. You earn $4.50 per dog. This per is telling me multiply. We can let D be dogs. I'm going to set it up so that it's a one-stepper, either using the multiplication or division property of inequality here. So I have $4.50 per dog. That's what you're going to make. And you want to earn at least is going to be a greater than or equal to 75. So you want at least $75. More would be better. More dogs you walk, the more money you'll make. Here, let's find out what the minimum number of dogs you would have to walk to earn at least $75. So solving this would mean taking the 450, B, dividing by 450 on each side. Division using maybe a calculator will give you D is greater than or equal to approximately 16.7. Now, I'm not going to walk 0.7 of a dog. So if you want to make at least 75, you're actually not going to be able to earn exactly 75. That's not a possibility here. You're going to have to walk whole dogs. And so you must walk at least 17 dogs to reach your goal. All right, here's another one. It says a student club plans to buy food for a soup kitchen. A case of vegetables costs $10.68. So if C represents a case of vegetables, we've got 10.68 C. And the clubs can spend at most is going to be a less than or equal to symbol. $50. We've got to stay underneath that $50 mark. So we're going to take 10.68 C, divide by 10.68, divide 50 by 10.68, and we get C is less than or equal to, in this case, about 4.7. So when they ask the question here, what are the possible values or possible number of cases the club can buy? The club can buy anything less than or equal to 4.7. If we can only buy whole cases, the club can buy 1, 2, 3, or 4 cases. All right, last one here, dividing by a negative number. Take the negative 9y here into 63. I'm not going to write my symbol yet. Divide by negative 9, divide by negative 9. Because I'm dividing by a negative, reverse the direction from the original problem. We have y is greater than or equal to negative 7. So negative 7 here, closed circle. Go to the right, just to prove that this works here. A value greater than negative 7 that I could try here would be maybe negative 6. So if I plug in negative 9 times negative 6, less than or equal to 63, that's 54 is less than or equal to 63, that checks out. Right here we have negative 5x divided by negative 5, negative 10 divided by negative 5, divided by a negative, reverse inequality, x is less than negative 2. Alright, if you could do your section summary, don't forget, you might want to write something along the lines of, we learned that with the multiplication or division property of inequality, we need to remember to flip the inequality symbol, reverse the direction when we multiply or divide by a negative.